Welcome to 7.3 Adding and Subtracting Radical Expressions. We're mostly going to be using the distributive property to add like radicals. So that's our first vocab term. Two or more radical expressions are called like radicals when they have the same index and the same radicand. So remember, index is the little guy up here, whether it's squared, cubed. Radicand is the number or letter underneath here. So for instance, a square root of 2 and 3 square roots of 2 are like radicals because they have the same index. So when it's not written, that's a 2. And they have the same radicand. It's a 2 underneath. Whereas the square root of 3 and the cube root of 3 are not. While they do have the same radicand of 3, this is a squared and this is a cube, so those are not like radicals. Anytime that we have a like radical, we can add them or subtracting by adding and subtracting their coefficients. So remember, a coefficient's just the number in front of the variable. For instance, like if we had an expression 3 or 2x, 2 would be the coefficient. But if we're talking about radicals, so it would be the number in front of the radical. Here it's the number in front of the variable. In radicals, it's the number in front. So in these examples up here, 3 would be the coefficient and 1 would be the coefficient here if it's not written. So let's combine these radical expressions. If we can combine them, that means they have to be a like radical. So we need to look at their index, squared, squared, and squared. Square root, and square root. Do they have the same radicand? Well, this is a 7, 7, and a 7. So they are like radicals. We can combine them by adding and subtracting their coefficients. So basically, these are like terms in the sense of algebra. We're going to keep the index and the radicand the same. So it's still the square root of 7. But let's look at their coefficients. We have a 1 out in front here. Remember, it's hidden. We have a 5 here, positive 5, and we have a negative 2. So a 1, a 5, and a negative 2. 1 plus 5 is 6, minus 2 is 4. That means the coefficient out in front is 4. Let's hop down here and find our like radicals. So we have a square root of x term. That's a cube root of 4, so we're not going to circle that one. Well, here's another square root of x, so I'm going to circle the coefficient in front of it, and that includes the sign. And this is a cube root, so that wouldn't match this radical over here. But these would be like radicals because they're both cubed, and they both have the same radicand of 4. So I'm going to box those in to remind myself that I'm going to combine my circles and then combine my boxes. So on my circles, I have a 6 and minus 5. And on my squares, I have a minus 1 and a plus 2. So my circle terms are the square root of x's. 6 minus 5 is 1. I don't really have to write that one. Now on my square terms, it's a cube root of 4. And my coefficient is a negative 1 plus 2, so that'd be a negative 1. And I'm not going to write the negative, or I'm not going to write the 1, but I am going to write the negative. It's a subtraction. So this one's an expression of the square root of x minus the cube root of 4. Down here, again, I'm going to circle and box in some like radicals. So it looks like this is the cube root of x, and this is the cube root of x. Square root of x and the square root of x. Now I just combine the coefficients. 3 plus 2 is 5. There's 5 cube root of x's. I have a 1 minus 8, so that'd be a negative 7 square root of x's. Now sometimes it's not always apparent that we have like radicals. So we have to simplify this expression before we can add them. Okay, Just a little short study tip over here. The square root of a plus the square root of b is definitely not equal to the square root of a plus b underneath the radical. And this gives a better example. Like the square root of 6 plus the square root of 3 is not the square root of 9. Okay? Don't do that. They are two different numbers. The square root of 6 is some decimal number plus the square root of 3 is some decimal number, and you're not going to get the same answer. All right, off of my soapbox, back to this problem. How am I going to simplify this in order to get radicals? Well, let's break down the square root of 45x. So it's a square root, so I'm looking for perfect squares in this product here. Well, two things that multiply to 45 and one that's a perfect square would be 9 times 5. 9 times 5 is 45, and this is helpful because 9, I can square root it. And then, of course, it's 45x, so we have to take it times x. Over here, I have a 3 for my coefficient, but let's simplify underneath our radical. 20 can be written as 4 times 5. The reason I'm picking 4 times 5 and not 2 times 10 is because 4 is a perfect square. So I'm trying to write 20 as two numbers multiplied and one of them at least a perfect square. And then obviously times x. So now I'm ready to simplify this because I'm taking the square root of 9 times the square root of 5 times the square root of x plus 3 times the square root of 4 times the square root of 5 times the square root of x. So the square root of 9 is just 3. The square root of 5 I cannot simplify, and the square root of x I cannot simplify. Over here, the square root of 4 is 2. Can't simplify square root of 5, can't simplify square root of x. So what this is if I multiply these back, I get 3 square roots of 5x plus 3 times 2 is 6 square roots of 5x. Now I have like radicals. My index is 2 on both of them, and my radicand is 5x. So I have a 3 plus a 6, and I get 9 square roots of 5x. Down here, I'm going to do the same thing. I'm going to look for perfect squares. So it's 5 times the square root of x squared times x, because I can write x to the third as x squared times x. Over here, I'm going to rewrite my radicand as 4 times x and simplify this. I have 5 out in front. The square root of x squared, remember the square root and the square cancel, so that would just leave me with x. But I still have x underneath my radical. It didn't cancel with anything. Over here, I have x out in front. It's being times by the square root of 4. Well, the square root of 4 is just 2. And I can't simplify a square root of x underneath. X times 2, I could rewrite as just 2x. So now I have like radicals. I have an index of 2 and a radicand of x, index of 2 and a radicand of x. So I'm going to combine these coefficients of 5x minus 2x. That leaves me with 3 x's and my radicand of x. Last one on this page. It's 6 times 24x to the 4th, and minus 3 times the square root of 54 over x to the 4th. So I'm going to break this up, and 6 is 6 over 1, correct? So I'm just going to leave the 6 in the numerator, and split this up into the square root of 24. Better yet, let's do this all in one step. The square root of 24 can be written as 4 times 6. Remember, we want to write 24 as multiples of perfect squares so that the square root of 4 will eventually cancel. And then I have a square root of x to the 4th, so that's x squared times x squared. I'm going to do the same thing. I'm going to put the 3 in the numerator, and the square root of 54 I can write as 9 times 6. Down below I have the square root of x to the 4th, which is x squared times x squared. Remember, I'm rewriting these under these radicans so that I can simplify it. So I have 6 out in front. The square root of 4 is 2. And I cannot simplify the square root of 6 anymore. Down beneath, the square root of this x squared, remember a square root and a square cancel, so I get x. Well, same thing here. So I have 2 x's, x times x. Over here, square root of 9 is 3. So I have this 3 out in front. The square root of 9 is also a 3. And then I can't simplify the square root of 6 anymore. Down below, I'll simplify to x times x, just like I did over here. Let's simplify this a little further. 6 times 2 is 12. Square root of 6. X times x is x squared. 3 times 3 is 9. And square root of 6 over x squared. Why can I subtract these numerators? Well, because they have a common denominator. So 12 square roots of 6 minus 9 square roots of 6 over x squared. These are like radicals because the radicand is 6 and the index is 2. So 12 minus 9 will give me 3 square roots of 6 over x squared.